All right, so let's move on to problem number two. This is a nice problem, actually, not too complicated. Uh, Number two, the title of it is SOHCAHTOA, right? SOHCAHTOA. And SOHCAHTOA stands for the definition of sine of theta. The sine of an angle theta, so let's say you have an angle here in this triangle, theta. The way that we define the sine of the angle theta is just by taking the opposite side length and dividing by the hypotenuse. Okay, so with respect to this angle theta, the opposite is the side length that is opposite the angle across from it. And then the hypotenuse is always the angle that is opposite the 90-degree angle. So if we label these sides here, this is with respect to the angle theta, the side length E is opposite. D is the hypotenuse, and F is what we call the adjacent. Adjacent just means to the side of, or beside. And notice that the side length F, that side is right beside the angle theta. E is opposite, and then since D, side length D, is opposite the 90-degree angle where this little box occurs, that is the hypotenuse. So sine of theta is defined to be the opposite side length, which has length E, divided by the hypotenuse over D. And so you can see here, we wrote it as opposite divided by hypotenuse. That's E divided by D. So cosine theta, so SOHCAHTOA, tells us that cosine theta is equal to, and I'll write it here, I guess, adjacent over hypotenuse. And that would be the adjacent side length has the variable f, hypotenuse is d. TOA is for tangent of theta. So tangent, no, I'll write the name out actually. Tangent. Cosine is pronounced cosine, S-I-N-E, and then sine is the full name of it is S-I-N-E. Sometimes people call it sin, but it's sine of theta. So those are the names. Tangent of an angle theta is, according to SOHCAHTOA, OA is for OA, and that is the opposite side length, opposite, divided by adjacent. And in terms of the variables, that is E divided by F. Yeah. So here's a fun fact. It turns out that tangent theta is also equal to the sine theta divided by the cosine of theta. And we said sine of theta was E over D in this problem that's given to us. Cosine of theta for this triangle was F over D. And so if we divide these fractions we learned in this class, we can divide fractions by multiplying by the reciprocal of the second fraction. And so the D's cancel, and we get E over F, which is exactly what we said. SOHCAHTOA gives us the same thing, but sometimes it's helpful to know this identity here, that the tangent of theta is equal to sine over cosine. All right, and then we are, away from SOHCAHTOA. That gives us the ratios for the first three trig functions. Now we are on the cosecant trig function, secant, and cotangent. Okay, so cosecant, it turns out, is just the reciprocal of sine. It's 1 divided by the sine of theta. And so it turns out to just be the reciprocal. It's going to be hypotenuse over opposite. Just flip the sine fraction over. Secant of theta is 1 over cosine of theta, which is, since cosine is adjacent over hypotenuse, secant is just the reciprocal. Hypotenuse over adjacent. And then cotangent of theta is 1 over the tangent theta. These are called the reciprocal identities. Okay. So cosecant, secant, and cotangent are just the reciprocal of either sine, cosine, or tangent. Oops. Okay. So tangent, cotangent is, and I always have to remind myself, cotangent is reciprocal of tangent. So cotoa says opposite over adjacent, so adjacent over opposite. All right. And so that would be D divided by E, D divided by F, and F divided by E. I just took, these pairs and swapped them. I did the reciprocal of these pairs here. All right, so that's problem number 2. I'll stop the video here and then work on problem number 3 next.